Hello, this is Alex Yazdani. My lab partners are Tim Liu and Szymon Gorski. This is for EE533 in the spring of 2025 with Professor Young Cho. So we have Lab 6 to demo right now, and I'm going to start off by just letting Tim talk about the IMEM and DMEM, and then we'll get to the pipeline.
Here I want to show that we're able to program our instruction memory with whatever instructions we want. So here is the sample instruction, which is in in binary form, and then I have converted into hex as well for checking our to see if we actually were able to program the correct instructions into the instruction memory. And so first, let's program the let's first program the FPGA, and then we do a reset, and then here we do program, and it takes whatever file that we provide, and you can see a finished writing. And then let's check if we actually write the correct instructions. So let's do read 0, and you can see this is 0, and this value should be the first instruction. Then we can hold on. Yeah, we can see actually a match, and we do 1, it also matches. We do 2, 3, and 4, and last one 5. Yeah, you can see it actually works. So yeah, thank you. Here I want to show that we were able to program our data memory as well. So here is the file for data, and then it basically just the instruction we just replicated twice. So here you can see it just replicated, and here's the corresponding hex. And since our data memory is 64-bit wide, so this will be for the upper 32-bit, and this will be for the lower 32-bit. And so let's see it. Here first, let's program the FPGA. And then we do a reset. And then we can program. And then if we wanna, we can just read. Oh, sorry, wrong command. As you can see, let me show the, where is it? Oh, this one, yeah. So as you can see, it matches. This is low, this is high, this is low, this is high, and they all match. And this is high, this is low, and also matches. And we just do another one, just see. Yeah, you can see here it also matches. So yeah, basically it just shows that we're able to take an input file and program everything and load everything into our data memory. Thank you.
All right, so this is just showing the pipeline. To start off, we want to download the bit file to the FPGA, and then have a Perl script here so we can check all the registers. And now basically we're using the command register as kind of our control signals. So if we want to manually write to IMEM or DMEM while they're inside the pipeline, we can do that, but we just need to set some select signals so that it takes the data from our input rather than the pipeline. So the first thing is pipeline enable. So as I typed pipe enable, you can see that this turns one of the bits to a 1 in the command register. Since there's no instructions right now, it's just bubbles, so nothing happens as expected. But if I turn that back off, then I can do imem enable and imem select. And this allows us to write to the instruction memory. So if I do program I and then instruction.text, we can see here that it just wrote 6 instructions to the instruction memory, and that's why the last address is I and the most recent data in is 93C. So now I want to disable this and just verify that it did disable, and it did. And now we can do the same for dmem. So now instead of instruction.text, we want to do data.text and program D. So and then we can see the output changed again for the data mem input and its address. So we know that that filled up. So now we can go ahead and disable these control signals. And then we can just go ahead and enable the pipeline, and yeah, we can see that it's processing data, and that's about it.